you still can see my screen, eh?
Yes.
Good. So let's discuss about the convolution theorem with respect to Laplace transform. So statement. So let f of t and u of t be two functions. So let f and g be two piecewise continuous functions. The convolution of f and g usually denoted by that's what we have. So the convolution of f and g is the integral from 0 to t, f of t minus b, g of v dv. So please note that convolution of f and g is the same as convolution of g and f. And when you say convolution of f, g and f, you define it as integral from 0 to t, g of t minus v, f of v dv. So when you reverse the order of the two functions, you still define the same, you still get the same answer. Also, if we let f of t Laplace transform of f of t to be given by capital F of S and Laplace transform of G of T the capital G of S, then so the convolution theorem can help us to find inverse Laplace transform of product of two transforms. So we demonstrate by examples. So in this problem, we have been asked to show that convolution of F and G is the same as convolution of G and F, where F is given by 2t and G is given by t cubed. So remember, everything comes from definition. So to find the convolution of F and G, it is the integral from 0 to t of f of t minus v multiplied by g of v dv. This by definition. So f of t is given by 2t. So which means that in this formula, we have to define f of t minus v will be given by 2 into t minus v. Simply the role of t is taken by t minus v. So which you may simplify as 2t minus 2v. And then g of t is given by t power 3, but the formula dictates g of v. So what will be the value for g of v?
T minus 3 into brackets cubed.
Sure.
V cubed.
Just the v cubed. Remember, these are things you used to do in pure math. So if you are given the input as t, so new input is v. So you take the same formula, only that the role of t is taken by v. So if g of t is t cubed, then g of v will be v cubed. Fine. So therefore, this implies that convolution of v, f, and g with the integral from 0 to t, where this f of t minus v will replace by 2t minus 2v, where this g of v will replace by v cubed, and then this is dv. So this will be the integral from 0 to t. So 2t v power 3 minus 2v power 4, and then dv. This is just normal integration problem. Remember, the variable for integration is v. In this case, v is a variable of integration. So anything that is not v in this expression is taken to be a constant. So by power rule, the first derivative will be given by
t v power 4 over 2.
power
Power
4 divided by
2.
By 2, because remember we have these 2 divided by 4 is a half, minus the next value, two v power
2v power 5
over 5, correct. And then remember, v is moving from 0 to t. So when you put in the upper limit, where there's v, you put t. So you'll have t times t power 4 over 2 minus 2t power 5 over 2 minus, where there's v, you put 0, so t times 0 power 4 over 2 minus 2 0 power 5 over 5. So everyone should be able to see that the lower limit will all
Yes.
go to 0. Okay?
The second part should be over 5.
Yes?
The second part.
This 5, eh? Yeah, this 5. This 5. Yeah, that was very beautiful. So the denominator there is 5. So this is 5. So t by t power 4. The t power
5.
So t power 5 over 2 minus 2 t power 5 over 5. When you put this together, add those two fractions.
1 over 10 t power 5.
1 over 10 t power 5, correct. So that is one way. Then second case is now to show that to define the convolution of g and f, whose definition will be 0 to t integral of g of t minus v times f of v dv. This is how we define the convolution of G and F. So we know that G of T from this question is given by T power 3. So which means G of T minus V will be T minus V raised power 3. So which will be T cubed minus 3 T squared V plus 3 TV squared minus V cubed. If you use binomial expansion, you should be able to get that. Then F of T is given by 2T. So which means F of V will be
2V.
2V, correct. So then now this will mean that the convolution of F and G will be 0 to T, and then T cubed minus 3T squared V plus 3T V squared minus V cubed. Then F of V is 2V dV. Please work out the final answer. And remember the limits of integration are for V. So V from 0 to V equals to T. Work out and see what you, let's see what you have. What is the final answer?
T cubed.
T?
T cubed V squared.
Okay, so now because of that variation, so let's just complete it together. So now the next step will be now you say integral 0 to T. So 3, it will be 2T cubed times V minus 6 T squared. And what is the power of V? I'm opening the brackets.
Square.
Squared. And then plus 6 T V power
3.
3. And then minus 2V power
4.
4. And then dV. So remember you are carrying out integration with respect to V. So V is from 0 to V equals to T. So what is not V is not respected. It's taken just to be a constant. So the first term, by power rule, you get T cubed
T cubed.
V squared over 1. Because that 2 will cancel the 2, okay? or if you like, you can put 2 over 2. And then minus 6t squared v cubed over
3.
3 plus 6t v power 4 divided by 4 minus 2 v power 5 over 5. So we are sure that the lower limit would be 0. Able to see that? Because everywhere there's a v.
Yes.
Yeah. So therefore, we'll have 2t cubed. Where there's v, put t minus 6t squared. Where there's v, we put t plus 6t t power 4 over 4 minus 2t power 5 over 5. So it's like I'm having then this minus 0. So when I simplify the first term,
T power 5.
t power 5. Second term,
2t power 5.
2t
Minus
power,
2t power 5.
and then third term, 3 over 2 t power 5, and then minus 2 over 5 t power 5. So just add 1 minus 2 plus 3 over 2 minus 2 over 5. What do you get?
T power 5 over 10.
1
T
over
power 5
10
over
T
10.
power
Yeah. So then you don't need St. Peter's to see that the two are the same. So clearly the convolution of f and g is the same as convolution of g and f, which is t power 5 over 10. And it will always be true for any two functions, f and g. If you reverse the order of convolution, answer remains the same. So example 2, use convolution theorem to find the inverse one over s plus 2 and s plus 3. Remember, it's always good to know all these methods of finding the inverse transforms, because sometimes a question can be specific to which method you have to use to get the answer. So you have to stick to the instructions of the problem. If the question is open, then you are free to use any method of your choice. But if the question specifies the method you are supposed to use, then you have to follow that. So write the problem. So remember the statement of the convolution theorem is the inverse of the product of two transforms, the same as convolution of the functions that gave rise to those transforms. This by definition. if we have 1 over s plus 2 times s plus 3, it is not hard to say that this can be written as 1 over s plus 2 times 1 over s plus 3. So then we can say this is what is the product of capital F of s and g of s. So we are claiming that capital F of s is what is 1 over s plus 2, and capital G of s is what is 1 over s plus 3. And you are very senior in this game. If you know capital F of s, you can always find f of t. So the inverse of capital F of s is what gives us the f of t. And what do we have if we have 1 over s plus 2? From our Laplace transform tables, f of t will be?
E raised to power negative 2t.
Correct, e raised to power negative 2t. That's by definition from the Laplace transform tables. And the inverse of g of s will give us the g of t, which is e power?
E minus 3t.
Correct. So that's what we have. So we have everything because we know what convolution of f and g is. So the inverse of this product will be the same as convolution of f and g, which is 0 to t, f of t minus v, g of v dv. That's by definition. So now, given that we have found our f of t to be e raised power minus 2t, then f of t minus v will be e raised power minus 2 into t minus v, which is e raised power minus 2t plus 2v. And g of t is given by e raised power minus 3t. So it will be e power
E power negative 3v.
correct. So we have everything in the convolution formula. So therefore, convolution of f and g will be 0 to t, e raised power minus 2t, but then you can write this one as e raised power minus 2t times e raised power 2v. E raised power 2v, and g of v is the same as e raised power minus 3v. But remember, this is integral with respect to v, so t is a constant, so I can pull it out. So e raised power minus 2t 0 to t. What will be the new power for e in terms of v?
-1 minus v.
Minus 1v, so minus v, okay? So e raised power minus 2t. Now, what is the integral of e minus v dv?
Minus E minus
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 e
v.
minus v, okay? Yeah, correct. So with this be e raised power minus 2t into the upper limit will be minus e raised power minus t. Minus will give me plus e raised power 0, or if you like negative 0, which is just e minus 2t into minus t, and then plus 1. So which you can write as minus e raised power minus 3t plus e raised power minus 2t, or e raised power minus 2t minus e raised power minus 3t. So get as many examples as you can and solve them using similar approach. So lastly, solving linear constant coefficient differential equations using Laplace transform method. So objective here is to solve initial value problems So one, if the differential equation is in terms of a function f of t, let capital F of s with a Laplace transform of f of t. Number 2, supply the Laplace transform operator on both sides of the differential equation. Supply L on both sides of the equation. Second last process, rewrite the algebraic question involving S and make F the subject. Capital F the subject. And then finally, find the inverse Laplace transform of F to find the solution. So let's give an appetizer. Solve solve this differential equation using method of Laplace transform. I know the problem is too easy. You can't get the answer. Because this simply separable differential equation. But that's not where we're going to get to obtain our answer from. So that was a method that we've done in second year, but now let's see how we can solve this by Laplace transform process method. So what is the first step? So the function here is in terms of
X.
x. So that's like the role of f. So we say let Laplace transform of x be given by capital X of s. So let that be the Laplace transform of the function x. So that is like I've done the first step. And step 2 of the method is to next step.
We put the Laplace transform operator on the differential equation.
Correct. So supply Laplace operator on each side of the equation. So we have applying L on both sides. We have Laplace transform of dx dt plus Laplace transform of x plus Laplace transform of 0. And remember, earlier on we gave the formulas for Laplace transform of derivatives. So how would you express Laplace transform of derivative dx dt in terms of capital X? It will be written as just check your book. What was the value of the Laplace transform of f prime of x was given as?
S capital
S.
Fs
And then
minus F0
at 0.
small f.
Correct.
Yeah.
Yeah. So this function as 0. Okay. So which we borrow the same formula. So this will be given by S capital X of S minus small x at 0, and then plus, by definition, this is capital X of S and the Laplace transform of 0. Laplace transform of 0. We have done several examples, should be able to know the answer. So at this point, we assume that you know how to find Laplace transforms and inverse Laplace transforms. That's what's assumed at this stage. So the Laplace transform of 0 is just 0. So in the equation itself, you are given the value of the function at 0, which is 3. So remember, this initial condition is not fashion. It is to help you solve the problem. So x at 0 is replaced by the number 3. So you'll have s x of s minus 3 plus x of s equals to 0. What do the next step?
Making f the subject.
Yes, make x the subject. So remember, we can say s plus 1 x of s equals to 3. So which means that capital X of s alone will be 3 over s plus 1. So once we successfully make capital X the subject, what follows?
Inverse Laplace transform of
Transform.
x.
Correct. So inverse Laplace transform of x of s. If this is what gives us now the solution x of t, which will be the inverse Laplace transform of 3 over s plus 1. So which can be written as 3 inverse transform of 1 over s plus 1. So you end up with x of t equals to
3e power negative
e
1t.
power negative 1t. Correct. So that is what you get in that case. Lastly, y double prime minus y equals to minus t squared. Y at 0 is given by 2. Y prime at 0 is given by 0. So this is the second problem and the last one. So quickly, our function here is in terms of, or what the name of the
Y.
function in this case? Y. So we'll say let L of y be given by capital Y of s. Then we know that next step is to find the Laplace transform of each side of the equation. So how do we write the formula for Laplace transform of the second derivative of y? Just check your work on expression of derivatives, Laplace transforms of derivatives. Second derivative will be
S squared f of
s squared.
s
So then y of s, and then
minus s y of 0 small
y
y
of 0, and then
minus y prime of 0.
y minus 0 should give us now what is the Laplace transform of minus t squared? Okay, so in fact, this is the answer for this part here, then plus or minus the Laplace transform of y, which is just y of s So this, all this one here is the Laplace transform of y double prime. And then next is minus capital of s, y, and then equals to, what is the inverse of minus t
1
squared?
over s 2 over s cube minus 2 over s cube.
Minus 2 over s cubed, correct. You just use your Laplace transform. But then we are like that the values of the function at 0 are given, and also the derivative at 0 are given. So we replace s squared y of s minus s times 2 minus the second derivative, the first derivative at 0 is 0, minus y of s equals to minus 2 over s cubed. So this is s squared y of s minus 2s minus y of s equals to minus 2 over s cubed. So what should we do next?
Make y of s the subject.
Make capital Y the subject. So this is the same as s squared minus 1 capital Y of s equals to minus 2 over s cubed plus 2s. And by the way, this will be s cubed minus 2 plus
2s power 4.
2s power 4, correct. So that means we'll have capital Y of s will be minus 2 plus 2s power 4 over s cubed into s squared minus 1. So be the same as, actually I can say 2 into s power 4 minus 1 over s cubed into s squared minus 1. But you should be happy with the bracket in the numerator. Are you saying that it's a difference of 2 squares?
Yes.
Yeah, it's a difference of 2 squares. So we have 2 into s squared minus 1, s squared plus 1, divided by s cubed, s squared minus 1. Please remember what is making us to say that it's a difference of 2 squares is s power 4 can be written as s squared, and then 1 can be written as 1 squared. So if you remember a squared minus b squared, it is a minus b times a plus b. So that's what we are using. And we are doing that one so that just